Okay, let's revisit the conditions for generally testing the overall significance. So from the previous chapter, when you have multiple regression, a regression is said to be significant if at least one slope coefficient is different from 0. And of course then we have the 6 conditions that must be true for us to be able to do the hypothesis test. And here we have 4 dummy variables, only 4 in the model. So our hypothesis test will be those 4 dummy variables equal to 0, which means it's not significant, and at least one is different from 0 would be significant. Okay, and we'll test it at 5% significance. Now from our output we have the F-calc value. So here we go back. So the 4th row, the first number is our F value. So we can increase the number of decimal places here. Okay, the numerator degrees of freedom is the number of variables. So here that is 4. The denominator degrees of freedom, that is our SSE degrees of freedom, that is given here in row 4 there. Okay. So now we can do a F table. F table is f.inv.rt. Okay. Then alpha and the 2 degrees of freedoms will give us the F table value. Okay. And if our F calc is greater than that table value, then we reject. So conclusion is reject the null hypothesis. The regression is significant. Okay. We can also do a p-value test. Okay, so for p-value we need to use f.dist.rt, and we use the f-calc value and then the 2 degrees of freedoms. So that will give us the p-value. So let's express that as a percentage. Okay, so this p-value is less than alpha, so we reject the null hypothesis. And then we have to come up with an interpretation. Okay, so we have sufficient sample evidence to conclude the regression between weekly sales and the TV advertisement option, so that is the 4 dummy variables, is significant. The probability of this conclusion, the probability that this conclusion is wrong is 0.023%. So here all of these interpretations is independent of which 4 dummy variables are actually selected for the purpose of running the regression analysis. Okay. And also the final conclusion will all be exactly the same no matter which 4 you select. So of course the one that is left out, if it is the 50-50 slot that is being left out, then all the comparison will be to the 50-50 option. So the numbers, the slope coefficients will be different. When you calculate it through, when you compute the actual forecast, then that would be exactly the same irrespective of which 4 dummy variables are included in the model and which one is left out, and that doesn't matter at all. So here one more thing. Now when it comes to dummy variables here, you cannot do a individual t-test because it has no meaning at all. Taken by itself, okay, there are 4 dummy variables here. You cannot separate one dummy variable from the rest. Okay, these 4 dummy variables combined together in combination represents the TV ad option. So either all 4 of them together will be significant, or all 4 of them together will not be significant. You cannot separate them and do an individual t-test for each of these except 1 through except 4. That has no meaning at all. So if you want to test, suppose if this is not the entire model, so besides these 4, so if you have other variables as well, so you can test the individual significance of the other variables, but when it comes to this group of dummy variables, you have to do the additional F test that we discussed in the previous chapter, and take this as a group, these 4 as a group. Never separate these 4 into individual or subgroups and then test for significance of that. So individual or subgroup significance has no meaning at all when you have a collection of dummy variables that represent one particular categorical variable. These variables cannot be separated.